Welcome back to Intermediate Algebra with Jeff Anderson. Here we're in Lesson 3, Video 12, where we're going to get more practice multiplying binomials. Here we see our next problem. We'll do what we always do, which is to read the entire problem out loud to ourselves real slowly to start. Expand each of the following products using distributivity or FOIL. In this case, our product is quantity x plus 2 times separate quantity x minus 6. After we've read the problem in full, we're going to ask ourselves the simple question we always lead with when we're looking at a math statement. Is there an equal sign? In this case, we say that there is actually no equal sign, which immediately implies we're going to do something called simplify the expression. Remember, we begin our solution simplifying by writing the entire problem out in our own handwriting. This is where I want to comment. Mathematicians do this really good job of confusing everybody but themselves. In particular, a lot of times when we're writing a multiplication, we suppress, we don't write that, and that kind of bothers me. I like to, when I'm rewriting these problems, specifically write the multiplication for myself so that I know what I'm doing. In this case, we might decide to do the right distributivity first, where we look at this as a unit and we pass that unit out through the addition. In other words, we're going to take that multiplication, give 1 to x, take that multiplication, give 1 to 2. This yields the product x times x minus 6 plus 2 times x minus 6. Once we're to this equivalent expression that came from right distributivity, we can actually now apply left distributivities. We're going to multiply this x by the first term, pass that multiplication through the subtraction, multiply that x by the second term, and the same thing is true here. We have a product where the left factor and the product is outside of subtraction. We can use left distributivity to pass that factor out. In this case, we see that x times x is x squared. X times 6 with a negative would be negative 6 times x. Here we have 2 times x is 2x, and then 2 times negative 6 is minus 12. When we're looking at this sum of terms, we see that there are no other square terms in the entire statement. X squared doesn't change. Here, the middle two terms are alike. In particular, we see that if I gave you $2 and then robbed $6 from you, I would have robbed a total of $4. In other words, minus 6x plus 2x is minus 4x. That's the difference between those. And remember that we call this particular process combining like terms. Since these two terms right there are alike, they both have x's in them. The last thing that we see in this specific example is that minus 12 is sitting around. There's no other constants in the entire expression. We say that we're done in this situation. We have now finished the entire process. We might say to ourselves, this is the simplified form. The way I did this here was through distributivity. We could also have used FOIL. I like to call this saran wrap or some other darn thing. I don't really like the idea of FOIL because, as I explained previously, I find that FOIL is the child, distributivity is the mom. I have a lot of respect for mothers, having watched my wife give birth. I'd rather go right to the source of the knowledge, but you could do this. Again, we're going to call this the first. We'll call that the outer. We'll call that the inner. We'll call this the last. If I just go first, outer, inner, last, x times x is x squared. X times negative 6 is negative 6x. 2 times x is 2x. 2 times negative 6 is minus 12. Once again, we follow up with the concept of combining like terms, just like we did in the process of distributivity. Minus 6x plus 2x, that's a total of minus 4x, minus 12. Lo and behold, we get the same answer out. FOIL allows us to skip the original step of right distributivity and gets us right to the middle step here, which was actually 2 applications of distributivity. In the next video, we'll explore a more general form of what we call quadratic expressions. See you there.